Okay, we're going to be talking about functions here in this this worksheet today, and it's really restrictions of where something is not a function. As the graph of function, and let me just review quickly. A function is any equation that has, well, it doesn't even have to be an equation, but anything that has an input. That input must have exactly one output. It can't have more than one output. Okay, and a quick way to test that is to do a vertical line test. And the reason the vertical line test works is because if we look at that point right there and we draw that the y-axis right through it, a vertical line test shows that if this is the only point that exists on that vertical line, then the one input that that vertical line represents at 0 has only one output identified by that one point there. Okay, in contrast to that, if we look over here, you look at that same input of 0, there's one output at +1, but there's another output at 1, 2, 3, or 1, 2, 3, -3. A vertical line will test that quickly because it's like having a y-axis that can float and move anywhere you want it to move. Okay, it's not always going to connect twice at a y-intercept like it does here, but if you do the sweeping y-intercept, even you can see right here that any point above and below is going to bump into this function. So that being said, the vertical line test will test each of these. This is in fact a function. There's no place where a vertical line will connect in more than one location on this graph. Same thing is true here. It'll touch once anywhere along that line, but it never touches more than once. But here, even though there's one place where it will only touch once, most of the rest of the places over here will touch twice. So is this graph a function of y? Yes. And the quick answer, if you say that it passed the vertical line test, in theory you kind of understand the vertical line test, the VLT, different than the bacon, lettuce, and tomato sandwich. Could be vegan, veggie, I don't know, but it really refers to the vertical line test. Okay, so graph the inverse. Well, that might sound easy enough to do, and there's a couple things you can do here. This point right here is the point 1, 2, and then 1, 2, 3, 4. It's the point 2, -4. Remember, we learned last week that if you switch x and y, that point will be an inverse point. So if I switch that, I'll get a -4 and a +2. So 1, 2, 3, 4, and down 1, 2. You put a point there, and in all of these, it's a 1, -2. Switch it up, it's a 1, and then -2. It'll be a -2 and then a +1. -2, +1, +1, -2. I gotta write it down. 1, -2. Switch it around, it's a negative. Oh, that's +2. Okay, that's why it's not working. Okay, good. Glad we caught that. Back 4 and then up 2. Back 4 and up 2. And then back. Okay, so this one was right. This one here is 1, 2, 3, and then 1, 2. So go back 2 and up. 1, 2, 3. Okay. This is on the y-axis at 1, 2, 3, 4. So it should be on the x-axis at 1, 2, 3, 4. And then there's this last point that's at 4, 4. You switch 4, 4. It's going to remain at 4, 4. So you graph this thing sideways, and you've got something that does not pass the vertical line test. Now that might seem a little cumbersome. So the answer is no, because the inverse doesn't pass the vertical line test. Well, let me ask you this. Is there some way that you might have been able to change your pencil on the original function that might have indicated that this thing, when you switch x and y, the whole switch x and y thing is sort of the key. A vertical line, as we saw earlier, is the y-intercept. Okay, so if you look at the y-intercept and just make it mobile, move it back and forth, that extends that vertical line test. Well, if we're looking at the inverse and we switch x and y instead of the x-axis, we can actually look at the instead of the y-axis, we can look at the sweeping x-axis. Now ignore the pencil line that I drew, but look at how this interacts with the original function. It crosses the original function more than once at these 2 points and these 2 points. Basically, any points that are next to each other will reveal that the inverse is not a function. And you can say, instead of a vertical line test, well, you can tell about the inverse by doing a horizontal line test. Okay, it's quicker than having to redraw all the points, but we can kind of hopefully see that there. Horizontal line test. Yes, because it passes the horizontal line test. We already said this is the vertical line test. And again here, this is not a function because it fails the vertical line test, But if you do the horizontal line test, the inverse is in fact a function because it passes the horizontal line test. Now, again, the assumption here is that the vertical line test means each input has only one output. You may want to consider that because there are going to be times where vertical line tests, horizontal line tests aren't necessarily going to explain the big picture, but there you have it.